and welcome to the module on transport emissions and traffic-related air pollution. My name is Marianne Hatzopoulou, and I'm a professor in the Department of Civil and Mineral Engineering at the University of Toronto. My expertise is in sustainable transportation. I study urban air quality, transport emissions, transport decarbonization. In this module, you will be exposed to some of these concepts, and you will acquire new knowledge relating traffic emissions with their impacts in near-road environments and ways to mitigate them. This module has 4 primary learning outcomes. First, you will overview the main air pollutants associated with traffic. This will allow you to understand the composition of the air we breathe in large urban areas where traffic is a major source of air pollution. You will also understand the formation of air pollutant emissions in internal combustion engines. Knowing how emissions are formed by a vehicle is critical to the development of solutions that can reduce emissions. You will learn how vehicle emissions can be measured. We will cover an important technique for measuring emissions in real-world environments. And finally, you will explore the different approaches to modeling emissions. Emission modeling is foundational to the development of greenhouse gas inventories. When cities produce inventories of total greenhouse gas emissions from different sectors, emission modeling is generally relied upon as a tool. Why is this knowledge important? Because transportation is associated with 2 main challenges that experts are trying to solve. First, transportation leads to climate change, and transportation leads to air pollution, which increases the burden of illness and therefore affects public health. Transportation is a main source of greenhouse gas emissions. The figure on this slide reflects the most recent greenhouse gas emission inventory of the Greater Toronto Area, illustrating that transportation is responsible for slightly more than 30% of total greenhouse gas emissions. So decarbonizing the transportation sector is a crucial element of climate mitigation. This can be done through investments in zero-emission vehicles and in alternative modes of transportation, like walking, biking, as well as in public transit. Transportation is also a main contributor to air pollution in urban areas. What we call commute level exposure means the air pollution you breathe when you're commuting on busy roads, whether you're biking, you're walking, you're riding transit, or even driving your car. And this exposure affects your daily dose substantially, even though you may only spend no more than 30 minutes each way per day. This is because air pollution is very high in near-road environments. While emissions from internal combustion engines have decreased substantially over the past 2 decades, epidemiological evidence continues to find associations between air pollution and health, even at the low levels that characterize many cities in the global north. An example of these health effects has been documented in the literature, and these include respiratory, cardiovascular, and even certain types of cancers. New research continues to unveil health outcomes associated with air pollution exposure, like cognitive and neurological effects. But transportation is changing very rapidly. We're witnessing the emergence of self-driving vehicles, of electric and connected mobility, and new forms of ride-sharing and ride-hailing. We're also witnessing new behaviors like trends towards e-commerce, leading to a rise in commercial movements that are replacing private car trips. The question is, are all these innovations helping cities move in the right direction? The direction being in terms of achieving clean, safe, efficient, and equitable mobility. Or is there more work to do to steer these innovations in the right direction? I hope you enjoy this short module, and I hope it equips you with enough knowledge to begin thinking through these multifaceted challenges.